In this video, we'll be seeing how to simulate traffic signal problem for getting average waiting time for all the vehicles coming from all four directions at a signal. The data for this problem is given. Okay, the signal has four sides. Um, Signal one is on for 15 seconds, second is on for 30 seconds, then third is on for 20 seconds, and fourth is on for 25 seconds. And to the arrival rate towards signal 1 is 200, that is from this side. Towards signal 2, that is from this side, it is how much? 300. And from towards signal 3, arrival rate towards signal 3 is 150, and towards signal 4 it is 200. Right, right. um These are here, it is not seen as 1, 2, 3, 4, but in sequence you understand towards 1, towards 2, towards 3, and towards 4. Right? These arrival rates are to be converted into per second basis because signal is the vehicles are arriving at high frequency, so it is better to have them in seconds, in per seconds. So 200 per hour means 1 by 18 per second. 300 per hour means 1 by 12 per second, 150 per hour means 1 by 24 per second, and 200 per hour will be meaning 1 by 18 per second. Now all these arrivals are random, they follow Poisson distribution. All right. So now our simulation, before we go on to simulation, it's very important to look how the signals will be operating. Signal 1 will be on between 0 to 15 second, and signal 2 will be on between 15 to 45. Signal 3 will be on between 45 to 65. Signal 4 will be on between 65 to 90, based upon the timing for which the signal is on. Then after 90 to 105 seconds, signal 1 will be on, and likewise another signal timing you can find out. Right? This signal timing will help us in finding the waiting time. Right? So we have in our simulation table sections, each section for a particular signal. First section for signal 1, second for signal 2, third for signal 3, and fourth for signal 4. Now, as far as first three column of any section are concerned, these columns how to have them in table, that you will know based upon the problems we have seen in earlier simulations. Like for example, in section 1, you will be having random number, random cumulative probability, and then inter-arrival time will be found by formula, that is 1 minus 1 by lambda into log of RCP. Okay, and for push signal, lambda is 1 by 18. So here you find that the formula will be minus 18 ln RCP. Likewise, in second section, inter-arrival time will be minus 12 in ln RCP. RCP2. In third section, it will be minus 24 ln RCP3, and in fourth section, inter-arrival time will be found out by minus 18 ln RCP, right? And based on this inter-arrival time, you can find out actual arrival time by doing cumulative addition. The first actual arrival time will be equal to the inter-arrival time, and subsequent actual arrival time will be found as sum of previous actual arrival time plus the prevailing inter-arrival time will give you actual arrival time for the concerned vehicle. Likewise, you will be finding out actual arrival time for all the sections. And once you get the actual arrival time, then when this vehicle will be getting through the signal will get you the waiting time. For example, first vehicle 16.18, you will be finding whether this time is falls in this lab. All right. 0 to 15, no it doesn't. So it will have to wait for this for making for being this signal on, and this signal on signal will be on at 98 seconds. So waiting time will be 16.818 minus 90 minus 16.18, that is 73.82. Okay. In second vehicle comes at 24.81. Again, it will have to wait for the signal to be on, which will be on at what time? 90th second, right? And therefore, waiting time will be 90 minus 24.81, that is 63.19. And for example, if you see here, vehicle number 6 is coming at 91.60, and that is the value within which the signal is on, so waiting time will be 0. So I hope you have understood the spirit or the method, the approach by which you are finding waiting time for individual vehicles, and this you will be doing for vehicles coming from all four directions. So, but while finding waiting time here, you will be referring to the signal on time for signal 2. For finding waiting time for signal 3, you will be referring to signal on time for signal 3, and likewise for signal 4, right? So you get waiting times for all the signals. For getting average waiting time, you will be making the sum of waiting times for all the signals, like here for all four signals, and you will be making total sum, which comes equal to 1219.46, and this you will be dividing by what do you say, 40, because from all four directions you have considered 40 vehicles, so average waiting time comes equal to 30.48. Okay. Now, if you change the signal timing, this will change and that will change waiting time, and that will change average waiting time. So, this simulation in that way will be helping you to find the best signal settings for which the waiting time will be minimum. For every change signal timing, you can find average waiting time, and whichever results in minimum average waiting time will be the signal timing for the will be the timing of the signal to be set. This way, simulation helps in optimization, right? So we stop here. I hope you will be able to do this simulation. Okay. Mm, just take the snap of this and try to do it yourself, or even without snap. If you have understood, you will be able to find the average waiting time. Thank you. Thank you very much.